Back normal. All right, so the first problem that we're going to do is y equals x to the third minus 3x squared minus 4x, all divided by 4x squared plus 12x plus 8. And at this point, we should be getting to the point where this stuff is boring. Is it boring?
Yes.
It's good. It's good when you get to the point where it's boring. It means you're really good at it. All right, so our y-intercept is what? 0. So plus 0, 0 divided by 8 is 0. What do we know about the horizontal asymptote? None, so it's a slant instead. So I'm going to do x to the third minus 3x squared minus 4x plus 0 divided by 4x squared plus 12x plus 8. It's not going to matter because you're technically not going to get there, but in long division, whatever goes underneath here is supposed to include every single term, and that's why I put the plus 0 in there. Okay, so 4x squared needs to multiply by what? 1/4 x. So we're getting rid of the 4, but we want a 1. All right, 1/4 x times 4x squared is x to the third. Doesn't my hand look ginormous right now? Like my index finger is the size of your face. All right, 1/4 x times 12x, 3x squared, and it's positive, right? And then 1/4 x times 8, 2x. And we draw the line and change, because we're subtracting. And that cancels to be 0 like it should have, so that's good. Negative 3x squared minus 3x squared minus 6x squared. Negative 4x minus 2x, and 6x. So here I have a 4x squared. I need it to be a negative 6x squared. So I'm getting rid of a 4. And what do I need instead?
Oh, 6.
A negative 6, right? So I'm getting rid of the 4. I need a negative 6. You okay with that part? We're going to simplify it when we write it down. Okay. So I'm just going to double check and make sure I did it correctly. So I'm going to do negative 6 over 4 times 4x squared. That's negative 6x squared. And when I subtract that, I draw the line and change my sign. And do I get 0? Yes, so that means I did it right. So my slant asymptote is going to be y equals 1/4 x minus, and now we can simplify that fraction, 3/2, 3 over 2. Marvelous. Okay, so we are comfortable finding the slant asymptote even when it's all fractions. Are we okay with that? Okay. All right, what do I do next? Factor. So the top has a GCF of x. So that leaves us with x squared minus 3x minus 4. Have you guys noticed that all the factors tend to be like the same set of factors? They're that way because we're fitting it on a small graph. If I was to change it up, your graphs would have to be a lot bigger. Sorry, it's kind of boring that way. All right, so we have x times what? And then when I factor that, x minus 4, x plus 1, okay. How do I factor the bottom? Take out 4. That leaves me with x squared plus 3x plus 2. 2 and 1. So it'd be x plus 2, x plus 1. So there's a hole at -1. So if I plug in -1 to the factors that are left, that's a -1 times -5, which is 5, and 4 times +1, 4. And so that y coordinate is going to be 5/4. The vertical asymptote is x equals -2. The domain is all real numbers, but skip -2 and -1. Do we have any x-intercepts? Yes. What are the x-intercepts? 0, 0, and 4, 0. So we have found everything. We are ready to graph. So I've got 0, 0, and 4, 0, and a vertical asymptote at -2. And a hole at -1 up 1.25. You guys have made sure that when you draw the hole, you put a circle there? And we make sure that when we draw a hole, the curve always goes through it. Whoa, slammy. And then we're going to draw our slant asymptote. So we have -3/2. What decimal is -3/2? -1.5? You were thinking 2/3. 2/3 would have been 0.666. So -1.5, and from there we're going to go up 1 and right 4. So up 1, right 4, up 1, right 4, down 1, left 4, down 1, left 4. Do you guys want rulers for today to do your slant asymptotes? Okay, so here is our slant. For those of you who came in because you're watching the video, this is your first assigned problem. We're doing it, it's not an example, it's actually part of your assignment, so you probably want to do it. And you should already have the paper on your desk. Alright, so at this point we are ready to graph it on our calculators. Go ahead and grab your calculator, make sure you got everything.
Are we going to watch the recording? Like, are we,
Of this?
Is that going to be part of our notes? Or
No.
Is this for people who
This
aren't
is
here?
for people who aren't here. Yeah.
I'm always dressed in that. That's the way that's on our back.
All right. Have we typed it into our calculator? And we are getting some other values. What did I just put? Did I just put in -3? Yes. It's alright. What? Did you check, is your window weird? Does your window need to change? Alright, we are all graphing it. That's why you're chatting, because you're plotting points as you graph?
Yes.
So your graph should look like this. I went extra far so that you guys could clearly see that we do have a maximum and a minimum on this graph. I wanted you guys to be able to see it. Okay. Are we drawing them? I should see everybody drawing. Why are you being sassy today, man? You just in a sassy mood? Feeling sassy?
Oh,
grumpy. You got the grumps. Alright. A case of the Mondays? It's Friday. You should be happy because it's Friday and you love math. Alright. Do we have our graphs drawn? Or we need some more time? Need some more time?
Yeah. Actually, just because I think he was going with it.
Bailey, did you finish your drawing?
Yes, I did.
Marvelous.
I don't know. They're talking over. I'm struggling anywhere.
All right, I need your attention back up here. So, if you look at the left curve, it goes up and then it comes back down. So what am I going to find on this curve? A max. So I'm going to do second trace. Option number 4. And you are going to hold down your left arrow until it goes all the way over there. And if you watch, as you hold down the cursor, it's going to tell you what x coordinates and y coordinates the cursor's at. You can watch this, it's getting less and less negative. Do you guys see that? The y coordinate is getting less and less negative. Negative 3.8. Now it's getting more negative again. You guys see that? So that means that we had gone over the maximum. If it's getting less negative and it starts getting more negative again. That means it went up and it came back down. Okay? So here is where it's... Sorry, I want to do that again. Here's where it's a little bit more negative. I'm going to press enter for left bound, and I'm going to hold it to the right, and I'm watching it get less negative. It's getting less negative. Now it's getting more negative again, so I know I'm on the other side of the maximum. Does that make sense? So this one, it's not a very steep increase, but it does go up and come back down. It's just very shallow when it does it. All right, so there's our maximum. I'm going to go ahead and label that on my paper where that maximum is because it's going to help us write our increasing and decreasing intervals. So negative 5.4 is about right in here. So I'm going to write, that's my max. And then off to the side on my paper, I can actually write the real coordinates there. So the maximum is negative 5.464, negative 3.732. And I do want you guys to include 3 decimal places because I'm assuming every single one of you is going into calculus next year, and that's what we use in calculus. All of you guys. You're in pre-calc, of course you're taking calculus next year. So since I'm assuming that, we're preparing for that. All right. Are we good with the max? Okay. You guys want to see another way to find the max?
Yes.
Okay. So go ahead and press this again. We're going to do second trace, maximum again. Another way to find it is to say, I know it is somewhere between negative 8 and the asymptote. You guys agree with that? Between negative 8 and the asymptote. So I'm going to say my left bound is negative 8, and I'm going to press enter. So I'm just typing in negative 8.
Oh, mine did like some stuff. I just went to go to.
So I did second trace, number 4, and I pressed negative 8 for a left bound. I didn't even scroll, I just said negative 8, and then I press enter. For right bound, I'm not going to type in negative 2 because that number is not actually on the graph, but I can do like a number that's slightly to the left of negative 2, which is a little bit more negative, so I'm going to type negative 2.001. That is slightly to the left of negative 2. Okay? And that's a good right bound. And the guess is always stupid, so I'm going to press enter one more time. So that's a way you can get the maximum without scrolling if you don't want to scroll. You know it's somewhere in there, but you don't want to look back and forth. That would work just fine. Yes, ma'am?
Mine says a mistake when I do that.
How big is your window?
I don't know how it goes.
It's because you hit the left arrow. The reason it's not letting you type in negative 8 is because negative 8 is not on your window. So your window has to be bigger than that. All right. Let's go ahead and find the maximum, or the minimum, sorry, minimum. So we're going to do second trace, number 3. And I have to choose a number that is slightly to the right of negative 2. And that's going to be our left bound. Damien, are you listening? Darius, you listening? Make sure you text them so they know how to do this. Like give them some instructions so they know. You text him? Make sure he knows. Okay. So the left bound for this one is going to be negative 1.999 because that's a little bit to the right of our asymptote. And then our right bound can be positive 8. Does that make sense how I chose those numbers?
No.
Oh, it didn't like that. I probably chose a number that was too close to the asymptote. Maybe try negative 1.9. It might like that better. And 8. Oh, actually, this is good to talk about. This is what you were talking about. If I choose a number to plug in that is not on my window, when I scrolled to the left, I moved my whole window to the left, and 8 was no longer on my window, and so my calculator would not let me plug in 8 because it was outside the window. So I'm going to go ahead and put 8 there as my X max. I'm going to try this one more time. That's why I was not getting an answer. Give it a second. Did you guys find the min already?
Yeah.
Okay.
Yes.
No.
Okay, so I've got negative 1.9 as my left bound. I'm going to type 8 as my right bound. And now since I have it as the window, it'll actually work this time.
Wait, so what's the left bound?
I did negative 1.9. All right, so our minimum is 1.464, so I'm going to label that on my picture. There's the min. All right. Was anyone happy to see the little stick figure man resurface for this? I missed the little stick figure. So we're going to put our little stick figure to the left. And what does he do first? He goes uphill. He is increasing until he hits the maximum. And then what is he doing after the maximum? Decreasing And then he hits the vertical asymptote and dies. He's gone. Okay. So at that point, we're going from left to right because we're Americans. That's how we do things. So the next part that's on the left is this part up here. So then we have a stick figure right here. And what is this guy doing? He's decreasing, he's sliding, and then he hits the hole, and he dies. He's gone. We got a new stick figure. What is this stick figure doing? He's decreasing for just a little bit, and then he hits the minimum, and what does he do after that? Increases. I like that sound. He shoots off. All right. So if we're going to go ahead and write our increasing and decreasing intervals, do we use the x or the y coordinate to do this? X. So the x coordinate at a left arrow, negative infinity. The x coordinate at the max, negative 5.464. And if you guys remember, with increasing and decreasing intervals, we always use brackets. We always use parentheses. We never, ever, ever use a bracket. Always parentheses. Okay, so he's increasing from negative infinity to negative 5.464, and then he decreases. So I'll write that in a second. And then here is decreasing and decreasing. So where is the next increasing? 1.464. to infinity. Okay. All right, for decreasing, where is the first place he starts decreasing? To the x value at the asymptote, which was negative 2. And then we have a different stick figure, so we have a different answer now. So he dies, and then our new stick figure starts. Where does our new stick figure start? What x value? He starts at negative 2. And that stick figure goes from negative 2 to an x value of... What's the x value where he fell in the hole and died? 1. Negative 1. Okay. And that stick figure died, so we started a new stick figure, and that new stick figure started at negative 1 and went to an x value of 1.464. Okay. Are we okay with increasing, decreasing?
No.
So when are the times when we have to start a new stick figure? When they die by falling in a hole or the asymptote. Okay. All right. We also need to write the domain in the interval notation. So we said we're skipping negative 2 and skipping negative 1. So I'm going to say negative infinity to negative 2, negative 2 to negative 1, negative 1 to infinity, okay? And then the range, we have to look at the picture and we're going to have to think it through. So the range goes from down to up. So if we look how far down the picture goes, I have an arrow going down. That's negative infinity. And if I follow it up from that, I've got negative 8, negative 7, negative 6, negative 5, and then what happens right in here? It stops. Do you guys see how the graph stops? And we have this gap right in here where there are no y values on the graph. You guys see that? Okay. So we go from negative infinity to the maximum. And we are doing a range, so we're going to use y coordinates. What is the y coordinate at the maximum? The y coordinate. Negative 3.732. With the range and the domain, we can use brackets if it's called for. So here, is this a real point that happens, or is it an asymptote? That's a real point, so we're going to put a bracket there. All right, we follow that? So negative infinity up to that maximum, then we stop. We have a gap. We have some y values that don't happen. And then what is the next lowest y value you can see? The min, yeah, the min is the next lowest y value you can see. Does that make sense? Okay, so I'm going to draw something. Please don't draw this on your paper because it'll make it a mess. But if you can see right in here, all these y values are skipped. Does that make sense? So the highest y value that I have down here is that maximum. The next lowest y value I have is at that minimum. Does that make sense? Okay, so then we're going to say u, and this y value was what? Wait, the y value. Negative 0.268. Does that get a bracket or a parenthesis? A bracket because you equal it. Okay. And then as we go up, we have a hole at 5/4. Is that y value skipped?
Maybe.
Yes.
It's skipped right here, but what is the y value right here? It's the same thing. So did we actually skip it? No. It could be skipped. Sometimes the y value at the hole is skipped. In this point, though, since it scooped down and came back up, we might have missed that y value over here, but we did not miss it over here. Does that make sense?
How would we know that?
You just, by looking at your graph. You just have to think about it. So if you know you scooped down and came back up, then you know that you hit it. So then we keep going up, and so this is negative 0.268 to infinity. It doesn't skip anything. Okay. And that is all of it. That's how you analyze a rational function and include all the characteristics that are important. Yeah, it's not the best. Okay.